All right, welcome to Geometry 4-4. This is angles of elevation and depression. And so first let's just start with these definitions, and you can see that they're in there in your workbook to fill out. And to do this, we kind of need to just first draw. You can see that we have a plane in the sky, and then a woman here that's kind of looking at the plane. And just to, before we get into the definition, let me just draw a horizon line here. So the horizon line from her eyes would be here. Okay. And then she's looking at the plane. Okay. So the angle of elevation is, I'll just write this in. This is the angle of elevation. And what that is the angle of elevation is the angle that's formed by the line of sight and the horizontal plane for an object that is above the horizontal plane. So I'll say that again. The angle of elevation is the angle formed by the line of sight and the horizontal plane for an object that is above the horizontal plane. So there's an angle that's formed, and the two things that form that angle is the line of sight to the object that is above the horizontal plane, and then the horizontal plane itself. That is the angle of elevation. I'm going to erase this because we're going to do some problems on here. But now let's look at angle of depression. To do that, I need to draw one more line here. This is kind of the path of this plane. This is our angle of depression. Now for the angle of depression, we're shifting our perspective from the plane. And so let's get to the definition now. It's very similar to the elevation. It's the angle formed, again, here's your angle, and we have two lines that are forming it, by the line of sight, it's looking down, and the horizontal plane for an object that is beneath the horizontal plane. So one more time, it's the angle formed by the line of sight and a horizontal plane, just like our angle of elevation definition, for an object that is beneath or below the horizontal plane. So those are two angles. Now let's solve a problem, but first I'm going to delete these words here. 1 second. Oops. Okay. All right. Okay, I just need to draw the windmill. We're looking at page 517 at the problem posed here. So let's say that you're standing 53 feet from the windmill turbine. So this is 53 feet from here to where you're standing. Your angle of elevation to the top of this hub here of the turbine is 56 degrees. So this is 56.5 degrees. That's our angle of elevation. Approximately how tall, and your height here is 5.5 feet. You're standing 5 feet off the ground. So the question is, approximately how tall is this? I'll go ahead and draw this line in here real quick. From here, coming down to here. How tall is the turbine to the hub? Well, let's look at how we're going to do this. Well, first let's label our unknown. What we're trying to find here is x. And we know that the tangent, because we're looking at opposite over adjacent. So the tangent of 56.5 degrees equals x over 53 feet. Right? To get x on the side, we'll multiply both sides by 53. And so then we would have x equals 53 times the tangent of 56.5. Now again, you need a scientific calculator to do this, but when you plug that in, you would get a total of 80.07. We'll just round there. Now, I was actually a little bit wrong before. The real question asking us is not just, my picture's a little off, but it would actually be to here. This turbine should probably come down this low here. We can't forget that we're standing 5 feet above. So it's not that the answer is 80 feet, although that's good. We need to add the 5.5 feet to get a total of about 85 feet would be probably a good guess or approximation of this. So from the top of the turbine to the very bottom, including your standing distances, it's about 85.5 feet. Okay, so the book's going to ask you more questions like that. Good luck. I hope this helps, and I'll talk to you next time. Bye.